All right, guys, I'm going to go through these examples one more time just to make it clear as possible. So the first one, remember that we're checking with composition, so we can either use f of g of x or g of f of x, and we want it to be equal to x in order to verify that these two are inverses. So I think we did f of g of x in class, so I'm just going to go through that process one more time for you. So to do this, the first thing I want to do is build a skeleton for f. So what I'm thinking about when I'm building a skeleton is wherever I see an input, instead of where that x is, I'm going to replace it with an open set of parentheses so that I know where that open set of parentheses was the input for that value. So that would give me 3 plus 2/3 and then a parentheses where that x was. Then what I'm going to do is I'm going to take whatever the other function is, which in our case we're talking about g of x, and put the expression for that in where my input normally is. So that would be 3/2 x minus 9/2. I actually think I'm doing it the backwards way from class, but this will also show you that it doesn't matter which way you go. So if I do this, I get 3 plus, I'm going to distribute my 2/3. 2/3 times 3/2 is going to give me 1x. And then 2/3 times negative 9/2 is going to give me negative 18/6, which ultimately that's just going to be negative 3. So this is 3 plus x minus 3. And then the 3 and the negative 3 cancel, and we're just left with x. Therefore, f of x and g of x are inverses. Okay, so that's a quick review of linear one. All right, let's go over here to this one and remind ourselves what we did in class on this one today. On this one, first thing I want to do is build a skeleton. I think what we did on this one as well was f of g of x. If I'm doing it backwards, no worries, either one will work. So in this one, if I do this, I'm building a skeleton for f. So right here where this x is, that's where I'm going to take that, leave it blank, and put a set of parentheses in. So negative 2 divided by parentheses plus 1. Quick reminder about what we talked in class. I'm going to distribute this negative and just assign it to the numerator rather than keeping it floating around if you were confused why the negative moved to the top. Then I'm going to take whatever the other function is, which in this case again is g of x, and we're going to drop the expression into those parentheses. So that'd be negative 2 over x minus 1. As I'm looking at this, I'm now seeing that I've got a minus 1 and a plus 1, which are going to cancel. So I now have negative 2 divided by negative 2 over x. Instead of doing division by a fraction, I can rewrite this as negative 2 times the multiplication of the reciprocal, which should be x over negative 2. Put a little imaginary 1 if it helps, but ultimately these negative 2's are going to cancel, and again I'm left with x. Therefore, f of x and g of x are inverses. Now, we kind of had already talked about that we expected the next one to fail, but we didn't get all the way through the algebra of the work that we did. So let's get through that algebra because that's the daunting part. First thing I'm going to do is I'm going to write a skeleton for my function. I think this time we did g of f of x. So I'm going to write a skeleton for g. So again, wherever I see x, a set of parentheses will go to hold that space. So that looks like this. 4 over parentheses plus 1 minus 2. And inside those parentheses, I will put f of x. So that would be 2 over x minus 3 minus 2. The next thing I'm going to do is on this denominator down here, this minus 2 and this plus 1, I'm going to combine those like terms. The opacity on that is really bad. Okay, when I do that, I get 4 divided by 2 over x minus 3, and the negative 2 and the plus 1 gives me negative 1. And then this minus 2 is still floating around here. Well, in order to keep simplifying, and I'm going to come over here because I know I'm going to run out of space, I'm going to get a common denominator on this piece and this piece, so that I only have one fraction on the bottom rather than a fraction minus a whole numeral. When I do that, the 4 on the numerator is just going to chill. The minus 2 is still back here somewhere. This becomes 2 over x minus 3 minus x minus 3 over x minus 3, because that's just an equivalent way of saying 1. Okay, well, now that I've got a common denominator, I can now do 2 minus x minus 3, and I'm putting parentheses there so I don't forget that I have to distribute that negative to both of those terms on the top of that fraction, over x minus 3, since they all have the same denominator. And then that minus 2 is just hanging around. Alright, and that's going to give me 4 over, this is ultimately going to be 2 minus, so this is going to be a minus x and a positive 3, so that's going to give me 5 minus x over x minus 3. And we still got a minus 2 hanging around out here. Equals, instead of doing 4 divided by that fraction, I'm going to do 4 times the reciprocal. So that would be x minus 3 over 5 minus x. And then all that minus 2. Then that gives me, remember I multiply that 4 on the numerator because it's 4 times 1. 4x minus 12 over 5 minus x. Still minus 2. Still, remember the goal of this is that we wanted it to simplify to x, and so far that does not look like likely, but there is about one more step I can take into account here. For this minus 2, instead of leaving it a minus 2, I need to get a common denominator with this piece. So these two I need to get a common denominator. Easiest way to do that is multiply the top and bottom by 5 minus x. So now I've got, ready, we've got common denominators. I've got 4x minus 12 minus 2 times 5 minus x all over 5 minus x. Well, let's see. That gives me 4x minus 12 minus 10 minus x all over 5 minus x, which gives me 3x minus 22 over 5 minus x. Okay, we finally reached the point where this does not simplify any further. Okay, so this is it. This is the simplest form, but this is telling me these are not inverses. Okay, so there's some good algebra in there, and those are skills we're gonna have to revisit because of rational functions. So good practice there. All right, one more that I said we would do that we have not gotten to yet. Here's our last one. So the first thing I'm gonna do, I'm looking at this and I'm thinking, which one do I want to do? I think I'm gonna do f of g of n. That's what I'm going with. So let's start there. So if I take the skeleton of f, now you might be looking at this and I'm going to put a parentheses around n. That means we're going to need a second set of parentheses than the one that's actually in the function. And inside that set of parentheses, we're going to put 4 plus the cube root of 4n over 2. So now I'm looking at this, and I notice that I need a common denominator again between the two pieces on the inside of the outer set of parentheses. And notice the denominator here is 2. So I'm going to change this 2 to 4 over 2. So that would look like this. 4 plus the cube root of 4n over 2 minus 4 over 2 cubed. Well, so I got the 2. I'm not going to mess around. I'm going to try to simplify some stuff inside these parentheses. This would give me a common denominator, 4 plus the cube root of 4 to n minus 4 all over 2. Well, now if we look at this, plus 4 minus 4, I now have 2 parentheses, the cube root of 4 to the n over 2 cubed. Alright, well, I'm now going to cube everything. So the 2's just chilling. The cube of the cube root of 4n is going to give me 4n on the top. But if I cube 2, I'm going to get 8. Alright, keep simplifying. This is 2 over 1. So now I'm distributing my 2 over 1. I get 8n over 8, which gives me n, which in this case n is our input. So F and G are indeed inverses. Okay.